An area of a trapezoid with polynomials. So we find area of a trapezoid using the formula a equals base 1 plus base 2 divided by 2 times the height. And sometimes you'll see that with a and b for your two bases, but in this case we're using subscript b1 for base 1, subscript with b2 for base 2, and your two bases are your two parallel lines. And then your height is your distance between those two parallel lines. So this trapezoid could be flipped upside down, it can be turned any orientation, but the bases are going to be the two parallel lines, and the height will be the distance between the two. Let's look at an example. So we have find the area of the trapezoid, and we have one parallel side with x plus 2 for the length, one parallel side with x plus 6 for the length, and then we have a height of 3. That's the distance between the two parallel lines. And we're going to substitute that in our formula for a trapezoid. A equals base 1 plus base 2 divided by 2 times the height. So our two parallel lines, x plus 2 and x plus 6, go in for the base 1, base 2. And they're interchangeable as long as they're the two parallel lines. And then our height, our h, will be 3. Now we're looking at simplifying the numerator. Well, I have some like terms I could combine. I can combine x and x to get 2x, and combine plus 2 and plus 6 to get plus 8 divided by 2. Then I could just simplify 2x plus 8 by dividing both terms by 2. If I divide the first term by 2, divide the second term by 2, 2x divided by 2 is x, 8 divided by 2 is 4. So I get x plus 4, and then we still have to multiply times the height of 3. So when I go to multiply the height of 3, it's just like using the distributive property. I want to make sure I multiply the 3 to the x and the 3 to the 4. So I get 3x plus 12. All right, I think you guys are ready to try one of these on your own. So pause the video here, and you guys find the area of the trapezoid using polynomials. All right, welcome back. Let's see how you did. So our two bases are the two parallel lines. We have x plus 16 and x plus 10. Our trapezoid, the orientation looks different. Looks like it was flipped over, but it could be turned sideways, flipped over. As long as we have a trapezoid, we're still going to use the same formula. We're going to put in our two bases, x plus 16 and x plus 10 in for the base 1 and base 2. And then our formula has that divided by 2 times the height. And the height in this case is 5. And the height is just the straight line showing the distance between the two parallel lines. And it could be one of the sides of the trapezoid. This one that was drawn in with a dotted line, but if it was straight up and down, was a vertical line between the two parallel lines, one of the sides could also be the height. So let's combine some like terms here in the numerator. We have an x and x combined to be 2x, and a plus 10 and plus 16 combined to be plus 26. Then 2x divides evenly by 2 to give us x. 26 divides evenly by 2 to give us 13. X plus 13 times 5. And putting this in parentheses helps us keep that we're multiplying 5 times the whole number of x plus 13. We're not multiplying it by parts of it, but the whole thing. So 5 multiplies to x to give us 5x. 5 times 3 gives us 65. And 5x and 65 cannot be added. They are not like terms. So the area of our trapezoid is 5x plus 65. I hope that helps you guys whenever you run into area of trapezoids with polynomials. Have a great day.